What if the last trace of humanity isn't on Earth, but drifting alone through interstellar space? Right now, billions of miles from home, a tiny spacecraft is traveling through the darkness between the stars. It no longer explores planets. It no longer belongs to the solar system. It is carrying something far more valuable, a message, a time capsule, a piece of humanity itself. Long after every city has vanished, long after the oceans are gone, long after Earth becomes nothing more than a forgotten memory in the history of the cosmos, this silent traveler will keep moving for thousands, millions, perhaps even billions of years. It may outlive entire civilizations. It may outlive humanity. It may even outlive the sun. Its name is Voyager 1, and its journey would become one of the greatest adventures in the history of exploration. Launched aboard a Titan I rocket in 1977, just weeks after its twin Voyager 2. The spacecraft took advantage of an extraordinarily rare cosmic alignment. For a brief window in time, the giant planets lined up in a way that allowed a single spacecraft to visit multiple worlds using gravity assists. A celestial slingshot powerful enough to transform an ambitious mission into an epic voyage across the solar system. Voyager 1 carried some of the most advanced scientific instruments ever sent into space. Cameras, spectrometers, magnetometers, plasma detectors, and sensors designed to study the invisible forces that shape our cosmic neighborhood. But attached to the spacecraft was something even more extraordinary. Not a scientific instrument, not a propulsion system, not a computer. A golden message to the universe. The Voyager Golden Record. A gold-plated copper disc containing images of Earth, the sounds of nature, greetings in dozens of languages, music from different cultures, and messages from humanity itself. A bottle thrown into the cosmic ocean. A message for anyone or anything that might one day find it. And etched onto its cover is a map, a way to find us. A cosmic address written in the language of pulsars. Because for the first time in history, humanity wasn't just exploring the universe. We were introducing ourselves to it. From the first day, there is no return planned. Voyager 1 is built to survive the vacuum, the cold, and the radiation long enough to do her work, and then to continue as long as physics allows. Voyager 1 reaches Jupiter, a world of chaos and lightning. Her cameras capture turbulence on a planetary scale. Wind speeds of up to 1,500 kilometers per hour. Storms rising and collapsing. Cloud layers stacking in complex patterns, and the Great Red Spot, a 16,000-kilometer wide storm that could easily swallow Earth. But the real surprise is not on the planet. As she passes Io, one of Jupiter's moons, scientists notice something incredible: volcanic activity, active eruptions on a world beyond Earth. Some of the plumes rise 100 kilometers high and are visible even from space. Voyager also studies Europa, Ganymede, and Callisto, Jupiter's other largest moons. In the images, Europa appears bright and smooth, crossed by dark cracks and streaks, hints of a surface shaped by ice and stress. Ganymede shows its own complex terrain, and Callisto appears ancient, heavily cratered. Then there is the invisible side of Jupiter, its magnetosphere. Jupiter's magnetic field is enormous. It traps charged particles and creates radiation belts far more intense than anything near Earth. Voyager's instruments measure those particles directly, mapping a space environment harsh enough to damage electronics. And after the encounter, Jupiter provides what Voyager needs most: a gravity assist. She swings past the planet, steals a small fraction of Jupiter's orbital energy, and converts it into speed and a new trajectory outward. Saturn appears as a pale globe encircled by rings. From Earth, the rings can look like a smooth, bright band. Up close, Voyager 1 reveals structure: countless ringlets, gaps, waves, and edges, each shaped by gravity and by the pull of nearby moons. The rings are enormous. They are mostly made of water ice particles ranging from dust to boulders, and they spread across hundreds of thousands of kilometers. Voyager studies Saturn's magnetosphere as well, and the moons that orbit within it. Some moons act like sculptors, maintaining ring edges and carving gaps. Others display surfaces shaped by impacts and internal processes. But the key target is Titan. Titan is larger than Mercury and wrapped in a thick atmosphere. It is the only moon in the solar system with an atmosphere dense enough to hide its surface completely. The atmosphere is dominated by nitrogen, with methane and complex hydrocarbons mixed in, and its surface pressure is about 1.5 times that of Earth's. Titan matters because an atmosphere this thick is chemistry in motion. Sunlight and energetic particles break molecules apart and reassemble them into heavier compounds. In the cold outer solar system, those compounds can form hazes, rains, and surface deposits. Voyager passes Titan at close range, bending her path and sending her on a trajectory that leads out of our solar system. In 1990, Voyager turns her camera back toward the inner solar system for the final time. From nearly 6 billion kilometers away, she captures a family portrait, a mosaic of planets. In one frame, Earth appears as a tiny point of light, the pale blue. Every human story, every dream, every thought compressed into a single pixel. After the family portrait, her cameras are shut down to conserve power. From now on, she is heading to the boundary of interstellar space at a speed of 17 kilometers per second. There is a final boundary, the heliopause. This is where the pressure of the solar wind is balanced by the pressure of the interstellar media. Crossing it is not like passing a checkpoint. Voyager does not see a change. She only detects it. As she approaches the heliopause, the particle environment shifts. Detectors register a sharp drop in particles that originate inside the heliosphere, and a sharp increase in cosmic rays that originate outside it. And on August 25, 2012, Voyager crosses the heliopause and enters interstellar space, the space between stars. In late 2026, Voyager reaches a distance of 25.9 billion kilometers, becoming the first human-made object to reach one light day from Earth. Light now takes a full day to travel one way between Earth and the spacecraft. A command sent now reaches her tomorrow. A reply arrives the day after. At the same time, Voyager's power supply is shrinking. The radioisotope thermoelectric generators that power her are losing output over time and over decades. That decline forces Voyager to shut down her systems one by one to conserve power and remain operational. Voyager has been traveling for 60 years. Her power has faded to a fraction of what it once was, and most instruments are silent now. NASA's current expectation is that she could remain within communication range of the Deep Space Network until around this time. But long before the final loss of contact, the scientific return will narrow to whatever the last instrument can measure. From Earth, she will not appear to die. She will simply stop answering. At this point, Voyager becomes what she has already been for most of her journey. A small traveler in deep space, moving along, unaware of whether she's being listened to. In about 40,000 years, Voyager will pass relatively near another star, Gliese 445. The closest approach will still be around 1.7 light years from it. The gravity assists at Jupiter and Saturn reshaped Voyager's path across the solar system. But beyond the planets, there are no convenient boosts. Between stars, the distances are so large that even a fast spacecraft becomes slow. By this time, Voyager's radio is silent. No one is tracking her with daily precision. No one remembers the engineers who built her. She is a relic of a civilization that might not exist anymore. By around 3 to 4 billion years from now, the scale of the story changes. Voyager 1 is no longer meaningfully connected to the solar system. She is somewhere in the Milky Way, a traveler whose exact location would be impossible to reconstruct with certainty. But the galaxy around her is not static. The Andromeda Galaxy, our nearest large galactic neighbor, has been approaching for billions of years. Over time, the gap closes, and it comes to dominate the sky. When the encounter begins, Andromeda and the Milky Way will pass through each other as gravity reshapes everything, and the two galaxies will merge into one. From Voyager's point of view, it will be a spectacular sight that will last for billions of years. The current age of the universe is about 13.8 billion years. 10 trillion years is roughly 1,000 times longer than that. By then, the familiar era of bright, massive stars is long over. Only the smallest red dwarfs can continue to shine for extremely long times. They burn fuel slowly, lasting for trillions of years. But even they do not last forever. As usable hydrogen becomes locked away and star formation slows, galaxies become collections of stellar remnants. The night sky becomes sparse. The universe becomes quieter. If Voyager has survived this far, she is now older than nearly every active star that once lit the Milky Way. Beyond the age of stars, the timeline becomes theoretical. One possibility is proton decay. Ordinary matter would gradually break down as atoms came apart, everything that exists would dissolve into lighter particles. If Voyager survives long enough, the universe itself will begin to erase her. She reached farther than anyone ever imagined, and her message remains that in the vastness of the cosmos, life looked up and reached out.